right, hi you guys. So in the last video, I wanted to actually cover problems 15, 16, and 17 in the same video, but it just got a little bit long and so I'm just gonna do those three here. Just a quick overview for you. This is homework alternate assignment for chapter 8 and 9. Today we're going to go over the logarithmic rules. Okay, and essentially, we can just write this in right now. You have log base A of x plus log base A of y. That's going to be log base A of x times y. Okay, let's color code a little bit. Base must be the same, base A. Okay. And then I'm not going to color code these arguments here. Just note that this x is in the argument of log. The y is separately in the argument of log, and these two logs are added together. Okay. What they equal combined is one log. Okay, and then the arguments are multiplied inside of a new argument. Okay, so one more thing, different color code here. When you have this side of the equation and you're looking for the other side, this is going to be called compression of logs. So that means you have more than one log, and the goal is to get to one log. Okay. If you start with the right side and you're trying to figure out what should be on the left side, that's expansion of logs. And that means you have one log and you want to expand to more than one. Okay. And I'm going to keep this the same for all three of the rules that I mentioned here, the three main ones. Okay, so I save that. You go ahead and erase this part. Okay, the second rule you have log base A of x minus log base A of y. That's going to equal log base A of x divide y. Okay, so where that comes from, this plus leads to a multiplication. This minus leads to a division. And then 3, you're going to have log base A. And inside of your argument, you're going to take that argument to a certain power. Kind of running out of colors here. Okay. The expansion for this is still going to be 1 log, but now you're going to bring this exponent down to the front. Okay. So it's going to be C log base A of X. This is product rule of logs, quotient rule of log, and power rule of log. Okay. Probably should have just done that on the whiteboard so it's not as ugly looking. So take a picture of that so you can follow along with this next bit. I'm going to go through these ones a little bit quicker than I went through the last videos. Okay, so the first bit, so fill in the missing values to make the equations true. For part A here, you can see that we have log base 5 of 2. Color. Plus log base 5 of 7 and equals log base 5 of something. So this is going to be your product rule of logs. And what it should equal is log base 5 of 2 times 7, which is 14. Okay. Part B, you can see a subtraction here. So we're going to be using quotient rule of logs. And essentially the quotient part and the product part is coming from the right-hand side, but it's still one equation. So we still call it our quotient rule. All right. So you have log base 4 of 11 minus log base 4 of something equaling log base 4 of 11 over 9. This is the part you're looking for. So the missing part, you should have log base 4. There should be a 9 there. Let me be specific with this last part, just the part you're supposed to fill in, okay? It's 14, so you would fill in a 14. You're going to fill in a 9. In this last part, we have log base 8 of 25 equals 2 log base 8 of something. Now this one's a little more difficult, right? Essentially what you want to do, you want to think about the log base 8 of 25 part. Okay. You're going to want to bring a 2 down from inside your argument. So how do we make 25 into a perfect square? Color code that part. Remember, this is the yellow part. Well, we would want 5 squared. Okay. If I expand this log, I get 2 log base 8 of 5. So you should fill in a 5 here. Okay. Save that. Clear that. Number 16 is next. We have log of yz to the 8th. And we want to expand this, okay? Each log should only have one variable and should not have any exponents, okay? All right, so basically one thing to note is if you don't see a base here, that means your base is 10. This is log base 10 yz to the 8th. Now, You wouldn't actually need to write the 10 in. That's just a helpful note for you, okay? Pops up later. We're just trying to expand this. So think about what's between in terms of operation inside the argument of this one log. We have a y times a z to the 8th. So times, and then we have this little 8th power up here. Okay, that should help you to realize. And you can do this in one part if you're comfortable enough, but I'm going to do it in various just in case you're not. So we're going to have log. That red mark there, the product, is going to turn into a plus sign on this side. I have a log. Okay, so in the second step, what's left inside? Well, we have log y plus log of z to the 8th power. Okay. The first log y doesn't need to change. Okay. And the plus stays. Now you're going to want to use the product or the power rule of logs to bring the 8 to the front. Okay, so log y plus 8 log z. Save that, clear that, and move to 17, which is going to be our last problem for this particular video. Okay, number 17 is our last one. Write the expression as a single log, so that means we're going to want to compress. This is killing me going back and forth between, I'm like, man, I just miss being able to use a solid pencil or a pen. Okay, so compress. So we're only going to want one log in the end. So we're going to do the same things here, except looking at the other side of our equation that we're starting with for our formulas. So you can see that there's a plus here. You can see there's a minus here. And you can see that there are coefficients in front of the first log and the second log. Okay, so the first step is to use the power rule of logs. All the coefficients are going to come up into the argument. Okay, so first step, we're going to have log base 7 of y. We're going to bring the 7th power in. So why am I saying that? Because there's 7 here, that's why. Okay, hold up, I don't have enough room. Let me just do this. Let me write all this stuff in black first, because all this going back and forth, multitasking is just making it confusing. So log base 7 y, okay, log base 7 w space, okay, there we go, and then log 7 z. Okay, now I can fill in everything. All right, first thing I'm going to do, I'm going to bring my coefficients up and make them exponents inside the argument here. So 1/5 and 3. Then I'm just going to keep my plus and minus signs right now. Now, if you're already comfortable with this, you can use this knowledge, but basically you only need to write one log from here. If this first, basically any logs with positives in front, they're going to be in the numerator. Any logs with negatives in front, denominator, and you're just using the arguments, putting them in the top or bottom. But let's do it step by step, as always, just to make sure we get So this first portion, product rule of log, log base 7. We're going to put a multiplication sign in here where that plus was. And then we're going to put our y to the 1/5. And we're multiplying that by our w to the 3rd. Okay. You don't have to put the multiply sign there. It's just to like emphasize where it's coming from, okay, where the change is being made. All right, now we still have this subtraction out here of a log base 7z. So that's going to be quotient rule of log. We have log base 7. And then in the numerator, we're going to have our y to the 1/5 multiplied by our w to the 3rd. And on the bottom, that subtraction is going to indicate this division here. And we're going to have z on the bottom. Okay. And that concludes this particular video. I will continue this over some time and post all these very soon.